good morning and midday and evening to all of you. My title today is about novel clean air technologies and indoor air interventions utilizing these techs. So the content shortly, I will introduce very shortly about VTT and our team Clean Air Solutions. Then introduce some challenges, some relation clean air in smart cities. The main part of my presentation is about the technologies and case studies utilizing those techs and a few ongoing future activities that we have at our table at the moment. So to put it in a nutshell, I would say the idea here is to highlight existing airborne contamination control technologies and present some scientific background, but also practical applicability of those novel technologies. But shortly, VTT is one of the leading research and technology organizations in Europe. We focus on applied research and global problems like carbon neutrality, like sustainable or resource scarcity, digital technologies, with over 2,300 employees. We have served lately over 1,000 customers, and our operating income is roughly 300 million euros. Our brand slogan is Beyond the Obvious, and that's how we usually try to think, let's say, different challenges to be one step ahead. Our clean air solutions, and now I see I'll show the our laboratory premises. So we focus on basically two areas: healthy air for people, like we are discussing today, but other branches about industrial ventilation and industrial filtering. We do have also some niche areas relating to decontamination, for instance, but the main thing is airborne contamination control in various forms. And the methodologies that we use is experimental. We have nice laboratories in a city called Tampere in Finland, with two measurement rooms for air purifiers and ventilation studies, two special test rigs for general ventilation filter and also industrial filter research and development work. And we have comprehensive computational cluster both at VTT, and we have also access to utilize our national computing clusters in Finland in research projects. So in many cases, we try to enhance the situation with the help of technologies, especially relating to air filtration, purification, and ventilation strategies. So to introduce very shortly about today's context, we had already two introductions, so I'm not putting too much on this. So of course we know air pollution is a global problem, outdoors and indoors, and the latest guidelines, for instance, from WHO, also highlight the importance of indoor air pollution. That's very important. And also they have highlighted these, let's say, emerging pollutants like ultrafine particles and black carbon. Pandemic and airport transmissions, like in the introduction, we were very heavily involved in national, but also EU level on pandemic and especially airborne transmission of COVID. So we had background already from SARS-CoV-1 times, also coordinating EU project at that time. But the third challenge is how to make this sustainably, how to make this, let's say, enhancement environmentally sound way, how make it economically feasible. And what I would like to stress here is how to make it in a socially just way globally. So, of course, the aim is healthier, more resilient city, and here are the tools that we typically have in our hands. So, moving to the technologies, of course, ventilation is a key issue. Here is, let's say, well-known picture about flexible ventilation systems. Uh, the left top about designing for maximum occupancy, so typically mixing ventilation and what is the maximum occupancy in a room and design the ventilation accordingly. But of course, we have in some cases demand controlled ventilation, especially in places where occupancy is changing heavily. We have improved air distribution, and that way we can direct the clean air to the places where it is the most needed. And the same applies also to this personalized ventilation. So in that sense, we can direct the air very efficiently to the place where it needs. But of course, it's kind of challenge in terms of flexibility. And of course, these are more about mechanical ventilation in buildings, but we need to remember that natural ventilated buildings are globally a big share. Then about air cleaning, here is a kind of list of the technologies typically utilized in air cleaning. We have focused on the three first ones: mechanical filtration, electric filtration, and adsorption in air cleaners, and mostly on particles, and of course with active carbon solutions to gases as well. And we have, let's say, background also in UV and optical radiation, and at the moment we are mostly interested about far UVC and its applicability. But the most important thing about air cleaners is its clean air delivery rate. So how much airflow goes through the device multiplied the filtration efficiency of the cleaner. And the pictures show that the cleaners may be also not always standing on the floor, but also integrated to ventilation system or may include some ductwork as well. So this slide is just to remind us that especially about fiber filters, filtration efficiency is very much to do with the particle size, and the most difficult size range is a couple of 100 nanometers, and you can, of course, enhance the mechanical filtration with electric forces to some extent. Here is an example of a combination technology that we developed some years ago with a Finnish company. It's called 3G filter. So the idea is to have a particle filter combined with gas filter and also UV for microbial inactivation. And I think this solution is starting to sound like 6G nowadays. So there is additional phases also incorporated, like more enhanced gas filtration if that is needed in some surroundings. If you combine that kind of, let's say, very efficient supply air filtration with room air filtration, here is an example of a concept that utilizes so-called clean air diffuser in a room. And with that kind of combination, you can reduce up to 90% particle concentration indoors compared to existing mechanical ventilation system. So the basic idea in this clean air diffuser, which is typically used for cooling and in Nordic countries and sometimes for heating purposes, is to kind of utilize the secondary airstream from the indoor air that has been induced by the primary supply air from the air handling unit through the device with very low pressure drop filtration. And with that, you can basically have a ventilation terminal unit and an air purifier in the same package. And that's just to showcase the graph that you can reduce, for instance, probability of infection. This is calculated from the Wells-Riley model up to, let's say, 1/5. And this has also commercialized by one Finnish company nowadays. Okay, moving to the case studies. Here is an example of utilizing air purifiers in daycare centers. It reflects to a big pandemic response project in Finland. We were curious to showcase that how much air purification, in addition to already good level of ventilation, can make a difference. So we had 2 daycare centers with air purifiers and two daycare centers without. And for first year, and then we changed the purifiers to the other daycare centers. So it kind of was a crossover study for 2 years, and the result was interesting. So we could reduce the incidence of illness among the daycare children by 18% by increasing the clean air with air purifiers. And I think this is very good results of practical research. This was our, let's say, thought that it will help, but now it has been also showcased in a scientific manner. So, and also with, let's say, medical doctors taking care of the sampling. So, of course, this has a potential for saving for illnesses of children and also for their parents that typically are absent during child's leave. So this was one example that was nicely highlighted also in national broadcasting company, but there's a lot more to dig in this E3 final report. So going a bit deeper in this case, one important issue here was that we utilized risk-based sizing of air cleaners. Of course, we would like to have had more cleaners, but there was a limited amount. So we needed to carefully think where we should install those. So what we did is to evaluate the existing ventilation, see the drawbacks there, and have a usage profile for the spaces where is most people at certain times. And then we use certain weighting factors that were calculated for each space. And for the risk or infection probability assessment, we utilized our own tool that was developed in this project. So based on this knowledge, we were able to ideally basically place the clean air purifiers to the places where it was mostly needed. And it looked like this in one of the daycare centers. So you can see with the red color that certain places like dressing rooms and dining rooms, in certain extent also group rooms and multipurpose hall, they were the most urgent places to place air purifiers. So to conclude, key steps from this study was that check the ventilation, find the hotspots, place the air cleaners, utilizing this risk-based sizing method. And perhaps fourthly, but not least, is to make sure that the air cleaners stay on because those little hands were all over the place in this case. So we utilized electric meters to check that the air cleaners were actually on. So Another case example I showcase here is to improve supply filtration. This was a case in East Asia, in a big city suffering from serious air pollution. Uh, we basically changed the filtration solution in one residential building, also made some quite detailed on-site measurements. And on the right, you can see the measured efficiencies of the original, pretty okay filters with F7 grade in Europe, and the improved filtration solution. So notable enhancement in the filtration with basically utilizing the same components in an air handling unit and a filter solution that had lower pressure drop compared to the original one. So we utilize this Li-Fi 3G system, electrically enhanced filter with the wire charger assembly. And of course, we need to take care also of ozone production that the wire charger may cause. So the filter is equipped with gas filtration media as well. And due to the continuous charge, it also keeps the filtration level very good. So we have experiences that with the 1 year plus case studies, it degrades only to, let's say, F9 or F8 grade. So much better filtration efficiency with lower pressure. So just to highlight some of the ongoing activities that we have, uh, of course, legislation is important. Here is a case from Belgium that I was privileged to take part. So after COVID times or during COVID times, they wanted to change their law relating indoor air quality, and the outcome was that, and I think it's important, is that you can utilize air cleaning in addition to ventilation. So after certain level, ventilation level, you can utilize either more ventilation or air cleaning to fulfill the requirement. And I think this is a good example that is also a proceeding in international standardization work. Other one is a project relating to ultrafine particles and black carbon, especially. It's an ongoing project where we focus on these emerging pollutants. In Finland, we have, let's say, very good monitoring companies, and the idea here is to leverage this kind of city level monitoring to indoor with, let's say, uh, cost efficient way. And our task here is about the countermeasures. So of course we focus on air filtration, but also to understand more about how the building envelope acts uh, in terms of ultrafine particles and black carbon. And the third one, perhaps my favorite, is the, let's say, costs and benefits of utilizing this kind of solution. So this is, let's say, example that we made relating to air cleaning solutions, comparing uh, costs and benefits in relation to fine particles and sick leaves. And I'm not going to go through the whole table, just to showcase that there are differences in the benefits, energy use, uh, how much investment those needs, and what are the basically total yield out of those solutions. And I would like to see more this kind of research and outcomes still to, let's say, help for the decision makers in different countries. So to summarize, I have here outlook of clean air in smart cities related to technology and economic and societal point of view. So in my opinion, I think we can achieve healthier air in a sustainable way, utilizing novel technology that actually already in many cases exist on the market. So it's more about courage and incentives to use them. Uh, from the economical and societal view, I think we all understand that air pollution is a risk for health and economic growth. Uh, Attention has been more on outdoor air pollution, so I see very important the value of indoor air quality, how that can be brought more to the spotlight, like with this kind of campaigns and project that we have here. So I believe that the development is market-driven, needs still steering through science-based guidelines and regulation. And perhaps to leave you with the, let's say, question is that how we can make that in the most just way globally in those places that require uh, better air quality the most. Thank you.